Hey, thanks for coming to my talk. I'm going to be talking about migrating your applications from Google Earth to Cesium. As some of you may know, Google Earth deprecated their plugin, and since then we've seen a lot of people moving from closed source and looking towards Cesium for an open source solution to avoid the vendor lock-in they've had with Google. Just a little bit about me. My name is Hannah Pinkos. I work for a company called AGI, which founded Cesium. I've been working on the Cesium team for 3 years now. I did some of the geometry primitive implementations and cleaning up the API. And I've also been working on answering questions on the forum. So I've seen a lot of people come ask questions for helping migrate their application. I'm hoping to clear up some of those frequently asked questions and point you to some resources if you want to migrate your own application. So just a quick overview. We're going to talk about the Google Earth deprecation, give a brief introduction to Cesium, talk about some of the similarities and differences between the two platforms, and then talk about data visualization using KML or other sources, and then finally the resources that we have available. So Google Earth announced their deprecation in December of 2014, and they initially said they would support it through the end of 2015, but they've extended that through the end of 2016 now. So they deprecated the Google Earth API. This means that there is no more Google Earth plugin. This was an NPAPI plugin for running Google Earth on the web browser. Most browsers have dropped support for these type of plugins for security concerns, so that was one of the primary reasons Google decided to end their to end the support for their plugin. This was pretty unexpected, and Google didn't provide any alternatives, any clear path forward now that they didn't have this available anymore. So we saw a huge influx of people looking to Cesium since it's an open source library and we're in favor of open standards. So just to show, this is a graph of our monthly forum posts, and you'll see when Google Earth announced their deprecation, we saw a major spike in people asking questions on the forum and wanting to learn more about Cesium. And we also, we've published a number of success stories on our website, including the NORAD Track Santa application for people who track Santa at Christmas time, and a number of different ones that I'll talk about throughout this presentation. Yeah. So this is a quick demo of Cesium. Let me see. This is supposed to be a video. There we go. It has a lot of the functionality that you may be familiar with Google Earth. We have the 3D globe with imagery. And so to quickly talk about Cesium a little bit, it is a JavaScript library, as I've said, for creating 3D globes and 2D maps. It's open source software released under the Apache 2.0 license, so it's free for commercial and non-commercial use. It's actively developed. We've been releasing monthly for almost 4 years now. And then it uses WebGL, which is an API for rendering graphics in a web browser. So there's no need for installation, no need for a plugin. It's cross-platform, cross-device, runs on Firefox, Chrome, on your Windows, Mac, or even pretty well on mobile devices. So to start out, this is one success story. A company called CloudAhoy migrated their application for recreating flights for debriefing pilots. So they said one of the things that they benefited most from switching to Cesium is apparently iPads are used a lot in the aviation industry. So they were excited they could get their customers using their application on an iPad. An overview of some Cesium features. We have support for terrain and imagery in a couple of different formats. Support for vector data using KML, GeoJSON, or a language that we developed called CesiumL. And also support for 3D models using GLTF. And these are two things that I think really sets Cesium apart. We have support for 3 different scene modes. So we have the 3D globe that can also convert to a 2D map. And we have what we call Columbus view, which is a 2.5D, which is like a flat map with height. So you don't have to do any kind of extra programming to get this. It will visualize your same data in each of these scene modes. Cesium is also great for time dynamic visualization. So if any kind of temporal geospatial data, it's good for that. Visual Cities was able to take advantage of our time dynamic capabilities. Their goal is to show some historical information about cities, like how they've developed over time. So using the Cesium timeline, they are popping in different different buildings depending on when they were built within a city. So when you're beginning to program using Cesium instead of the Google Earth plugin, there are a couple differences. One of the main being that Cesium is a JavaScript library, so it's going to be running in a web application. You need to know a little bit of web programming to get started. So you'll be using HTML for your page structure, CSS for styling, and then JavaScript for any of your kind of page control. So security is definitely important when you're thinking about a web application. Browsers discontinued support for the NPAPI plugins, mostly for security concerns, and that's what Google Earth plugin was based on. The plugins were essentially a C++ program that was running with the same permissions as your browser. So it could have unrestricted access to your local machine, including access to local resources and the ability to create new processes. These kind of vulnerabilities were prone to attacks, so that's why browsers discontinued support for the plugin. On the other hand, with Cesium, since it runs natively in a browser, in a sandbox, browser security extends to Cesium, so that's something that you don't have to worry about quite as much depending on your application. And finally, there are some network considerations. Since it's running in a web app, you have to load all your data from a server. You have to make XHR HTTP requests to retrieve your data, and browsers generally let 6 open connections at a time per server. So you may have to change some of the methods that you're using for loading data into your application. For example, a common practice that we've seen with KML is if you're loading in a bunch of models, you might have a KML file calling other KML files that call the models in, and having this many requests at once can cause some lag in your application. Large files can also cause lag, so this may lead you to have other formats for bringing in your data if you're using large formats like KMZ. Whoops. Another consideration is CORS, cross-origin resource sharing. This is a standard for web servers to restrict access to their data being read from web servers of other domains. You might run into this if you have imagery hosted on one domain and your application running on another, trying to grab that imagery. CORS is something that is disabled by default, so you're going to have to enable it on your server. And I found that enablecors.org is a really good resource for learning about CORS and learning how to enable it on your own server. Luckily, a lot of modern web services do have CORS enabled, so you might not run into this depending on where your data is coming from. Lastly, if you want to run your application offline, it just requires that you have all of your data hosted locally. So you're going to need your access to your imagery and your terrain and other things without having to access the internet. So now that we know about some of the differences between building a Cesium application and developing with Google Chrome, let's talk about data visualization. So we are working towards one-to-one compatibility with KML. So we have support for a lot of common features, such as geometry, like line strings and polygons, place marks. We recently added support for network links and style maps. So if you have a simple application that uses KML, your whole migration process might just be loading your KML into Cesium, depending on how complex that is. Let's see. Yeah, this is a demo that we have on our website that just demonstrates some of the KML capabilities we have. So this one is showing various different place marks with icon styling. And then the next demonstration is a KMZ file that visualizes the GDP per country, per capita. So that's all that stuff is packaged together in a KMZ. And then the last example is showing our use of the Google multi-track extension to recreate a bike ride. So we have support for some of those kind of things too that Google had. NASA, the folks at NASA JPL migrated their application called RapidScat to Cesium. It shows wind measurements that were collected from the ISS, and they said that they were able to reuse nearly all of their KML during their migration, so that made the process pretty easy. They did, however, change some of the ways their wind vectors were being displayed just for performance reasons, And they needed to implement their own selection tool because you need to do these things using HTML, which is something we'll talk about in a minute. So while Cesium does support a lot of KML functionality, KML is really not designed for the web because it can have really large files, especially with KMZ, and these can be slow to load. Data sets with really complex network links might have the issues with making too many requests, like we said earlier. And KML uses collada models, where Cesium uses GLTF instead, so you'd have to convert your models to GLTF. Another problem that we've run into is users will be loading their KML file, and there won't be exactly, or it won't run exactly as it did in Google Earth. This is partly because the KML specification is not exactly well defined, and then Google Earth adds a lot of functionality that's not in the official KML spec. So while we're striving for one-to-one compatibility, occasionally we run across these issues. So if this is something that you experience, definitely let us know about it, and we'll try to address it. But the good news is Cesium supports a lot of features beyond what it can do with KML. We have a really expansive API for developing all kinds of applications. Additionally, we support other formats such as GeoJSON, TopoJSON, and we've, as a team, have been working on developing new open formats that are meant for web visualization, such as CZML, 3D tiles, and GLTF. So CZML is essentially our answer to KML. It's designed specifically for Cesium, so you may see better performance if you convert your KML to use CZML instead. KML can be inefficient, and Google Earth could get away with this because it could use all the resources on your computer, essentially. But since Cesium is running in a web app, we decided that we needed a more performant solution. Also, CZML has more built-in features that Cesium has. So I've seen some crazy KML files that have made complex 3D shapes by having like 1 million different polygons put together to make these shapes. You don't really have to do that with Cesium because we have a lot of these 3D primitive types built in, such as like your boxes, cylinders, and cones. Let's see. Oh, the last thing is that CZML can be streamed. So if you have a really large data set, you may be able to break it into separate packets and stream it up to the application using server-sent events. So this might prevent some of the lag you'd experience if you have a really large data set. Whoops. The team at Tokyo Metropolitan University migrated their Hiroshima archive app to Cesium, and they found that switching from KML to CZML really improved their performance. If you want to learn more about this application, Dr. Hidenori Watanabe is presenting after the break in this room. So you can hear more about his experience. So for doing large data set visualizations, we helped develop the open specification of 3D tiles. Some of you may have seen the talk that Sean gave earlier, and we'll have those slides up online if you want to learn more detailed information about that. But essentially, it's a hierarchical level of detail structure for, so you only want to load in what you can see based on your view level, so you're not trying to render an entire city full of buildings at once. This has support for 3D models for doing buildings or instance models if you have tree data or anything like that, support for point clouds, and support for vector data. All right, so now we know a little bit about the similarities and differences between programming your Google Earth plugin and programming a Cesium application. So where do we start? The first thing that you're going to have to know is a little bit of web programming. We're going to be using HTML5 to build our application, so you need to know a little bit of HTML. You would use this to make your application layout and add things like screen overlays. So instead of with the Google Earth plugin where you do this from the API, you can do this directly with HTML for your form controls and your screen overlays and everything like that. And then we're using CSS to style those elements. So this is going to be used to change like the height and width and color of these different HTML elements that you've added to your page. And then JavaScript is what we are using to initialize Cesium and then control any behavior. So if you want something to happen when you're clicking on the page, you have to have a JavaScript function that is going to handle this. Two resources that I've found really helpful for this is for learning web programming is the Mozilla Developer Network, or also W3 Schools. They have a lot of interactive tutorials and information that you would need for getting started with web programming. And then for Cesium itself, we try to have really extensive documentation to help people get started with learning about Cesium and learning all the different capabilities that it has. All of this can be found on our website, cesiumjs.org. So we have tutorials and code examples and really extensive reference documentation for our API. In particular, we have a Getting Started tutorial, which is essentially, I just downloaded Cesium, now what do I do? So it'll show you how to add Cesium to your HTML page and how to get started from there. We've also built an application that we call Sandcastle, which is kind of like JS Fiddle for Cesium. So on half the screen, you have your code example. On the other half, you have your Cesium viewer, which is running the code from the example. So you can live code. You can see the different demos we have for how the code is doing the things in the browser. And I think that's really helpful. Additionally, we created an entire section of our website dedicated to migrating from Cesium to Google Earth. Especially after Google Earth announced their deprecation, and we saw this massive influx of people, we wanted to point them to like a direct resource that is geared towards their experience. This includes some one-to-one code samples, so it'll show you how we can do it with Cesium versus the code that the Google API used to do the same thing. And then we have a two-part tutorial series that kind of goes into more detail about some of the differences you may run into as you're migrating from Google Earth to Cesium. And lastly, we have some guest blog posts, so you can read about first-hand experiences from others' experiences migrating. And one thing that I think is really helpful is we have a really active forum. We have more than 900 members, about 500 posts a month, and it's supported by the Cesium team. So if you post a question, it's going to be seen by all these other community members, and it's also supported by us. So we try to make sure that no questions go unanswered. All right, coming soon to Cesium. We're working towards full 3D tile support for your large data set visualization needs. And one of the last things we have to do is vector data support. So we really want to have vector data on terrain, so we can have terrain on by default, which is one of the big differences between Cesium and Google Earth right now. So hopefully that'll be by the end of the year. Another exciting thing that we've been working on that should be coming out soon is support for shadows. So this really enhances your 3D visualization. And on Monday, we announced a new service that we've been working on called cesiumjs.com. We're in the process of getting people to know about it, but it's going to be a service for hosting and processing your data. Because we've had a lot of people come to us saying that they need some help on the data side of things. So they could use this service, sign up for a free account, and be able to host their data to stream to their new Cesium applications. And finally, we want to hear your success story. One of the things that I like most about working in open source is that we get to see all the cool things people are building on top of our applications, and then we try to showcase these on our website. So if you if you migrated your application and want to show it off, definitely let us know on our forum, and we'll try to get that up on our website. All right, that's pretty much everything I have. Are there any questions? Yes? I'm sorry? Whoop. Geocoder. Oh, the question was, do we have geocoder implemented? And yeah, so we have the Cesium viewer comes with a bunch of different widgets that are optional that we include with it. This includes a geocoder, the buttons for switching the different scene modes, or a widget for picking different base layers for your imagery, a couple of different things like the timeline and animation. Any other questions? All All right, well, if you have specific questions, I'll be here to answer them, as well as some other members of the team. So I'd be happy to hear from you. Thank you.